Hello and welcome again to the Data Science and Analytics track here at PyCon AU 2021. Next up from Mysore, India is Gajendra Deshpande. They hold a Master's in Technology in Computer Science and Engineering from, oh damn, I got the thing wrong. And also a postgraduate diploma in Cyber Law and Cyber Forensics from National Law School of India University in Bengaluru. They have presented talks and papers and been reviewer and program committee at more conferences and more continents that I can count. And Gajendra is also a GitHub certified campus advisor, and they lead the PyData Belagavi chapter, as well as the OWASP Belagavi chapter. In the talk today, Gajendra reminds us that time series is one of the important as well as lesser known fields of machine learning. In time series forecasting, we analyze the time-dependent data for predicting long-term and seasonally trends. Please give a warm welcome to Gajendra Deshpande and the presentation on time series forecasting techniques in Python.
Yeah. Thank you for the nice introduction. It is wonderful to speak at PyCon conferences always. This is my second talk at PyCon Australia online. So today I will be presenting a talk on time series forecasting using Python. So it will be a basic talk. So we will not be covering any advanced topics here. So in my talk today, today I will discuss introduction to time series forecasting techniques, then basic steps in forecasting, then time series forecasting techniques, then Python libraries for time series forecasting, and finally we'll summarize and we'll take up some questions. So we need to first define what is time series. So it's a collection of data points at constant time intervals analyzed to determine a long-term trend. So you can see here on this slide, there is a picture which is showing the temperature data. So temperature collected at various hours, and based on the historical data, we are going to predict the future trends. Say for example, we have collected temperature data for say around 1 month. Okay, then we are going to predict what will be the temperature next day, or maybe we are collecting the temperature data say for the month of September over the years, and we are going to predict what will be the temperature and what will be the weather for September 2022. So this is what we are going to do in time series forecasting. Of course, it is not only related to weather forecasting, anything related to forecasting and which is time dependent, we are going to forecast. And Python has got great support for these libraries. Now there are some application areas which I have listed. I may not be able to explain everything, but I will explain few. Say for example, weather forecasting I have just explained. So it may be used in agricultural industry, may be used by farmers also. So before sowing these seeds, farmer wants to know what will be the weather forecast for next few days, so that accordingly he can plan his farming activities. Then similarly, earthquake prediction. So there will be patterns of earthquakes. So what will be the area? What will be the environment conditions? Are earthquakes are happening in that area frequently? So based on that, they try to predict when the earthquake may happen. Then statistics at least has got lots of libraries and lots of applications related to forecasting. Then also in pattern recognition, then signal processing, control engineering, then mathematical finance, astronomy. So many applications are there. Maybe if I have to give one more example, then say for example there's a website and I want to predict the number of visitors in next few days based on the previous data. So historical data is very, very important for us. So based on that only we have to forecast. Now there are common time series patterns. So whenever we use time series, it is very important to go for visualization of the data. So that visualization of the data will give us uh, the patterns in the data. Okay, so you can see here there are 5 common time series patterns. So first one is level, then second one is trend, then next one is seasonal or periodic, then cyclical, then irregular fluctuations. So first one is irregular fluctuations. Irregular fluctuations are nothing but they are random in nature, and most of the times this data will be random. So we can't say that the data will always going to increase or data will always going to decrease. Of course, there will be a pattern in that, but irregular fluctuations is a random data. There is a lot of randomness in data. The next one is the trend. So trend shows whether the data is increasing or decreasing. So on this slide you can see that there is a line here, so which is growing, so that means the trend is increasing. Of course trend may be decreasing also, but in this example it is not shown. Then next is a seasonal or periodic. Okay. Uh, Say for example, in India we have got 3 seasons. One is rainy season, and second one is winter season, and third one is summer season. So there is a lot of temperature variation, and there is say for example in summer it will be a hot season, then in rainy season there will be a lot of rain, and in winter season there will be a lot of cold. So there will be different temperature in these seasons. Then similarly, uh, these seasons there are different periods. Say for example, some pattern may repeat daily, some pattern may repeat weekly, some pattern may repeat monthly, and some pattern may repeat yearly. Okay. In astronomy also there are some patterns. Say for example, uh, maybe the moving cycles or uh, the constellations, they have got some pattern of occurrence. The next is the cyclical. So in cyclical, we are going to have both patterns increasing as well as decreasing, but it will not be just one phase. There will be multiple repetitive phases. So you can see here that there is a upward trend, then downward trend, then again upward trend. So this is cyclical. Then again downward trend. So this is cyclical. So irregular fluctuations we have discussed that it's a random one. So these are the common time series patterns, and of course these also affects our results. Then there are some basic steps in performing forecasting. So first one is the defining a problem, then collect the information, then perform preliminary explorative analysis, then choose and fit model, then use and evaluate a forecasting model. So first one is the defining a problem, which is very, very important. So we need a problem to work on. We need a date. We need a problem to work on, and here we need to define what is our problem and what we want to achieve. So problem and goal should be defined here. The next is collect the information. So here we are building the data set by collecting the historical data. So we also need inputs from the domain experts. If you're a domain expert, you can directly work on it. Then perform preliminary explorative analysis. So in preliminary explorative analysis, you are going to use tools like visualization tools to identify the uh, kind of data pattern. And once you identify the data pattern, then you can select a model to fit. Okay. So in preliminary explorative analysis, you are basically trying to find out the pattern in the data by performing several operations such as visualization and so on. Then choose and fit a model. Here you are going to experiment with different models. So the one which gives you less error compared to the other model, you are going to select that. Then use and evaluate forecasting model in your application. So finally, you are going to deploy it in your application. Now these are the common time series methods supported by stats models package in Python. So first one is the auto-regression, then moving average. So these are the two basic time series methods. But if you see the rest, then they are the combinations of first two. And apart from that, the different parameters such as seasonality has been added to the basic methods. Okay. So first one is auto-regression, then moving average, then auto-regressive moving average, auto-regressive integrated moving average, then seasonal auto-regressive integrated moving average, then seasonal auto-regressive integrated moving average with exogenous regressors, then vector auto-regression moving average, then holtwinsters exponential smoothing, and finally the Dickey-Fuller test. Now, what happens in auto-regression is that we are going to predict the future based on the past data. So this past data is given as input to the regression. Okay. Then it will try to predict the uh, values. Okay. So we can just try to test this application. Okay. So before that, so let's see the source code. So what we are doing here is we are trying to import the package, import the model autoreg. Then we are also importing the random module because we want to generate the dataset random. This is just for an example, but you can really go for real world dataset. Then fit the model. So here we are using autoreg function, and it takes two parameters, data and lags. So here lags is the pattern. So here we want to predict the one value. Then fit the model, then make the prediction and print the prediction. Okay, so next is the moving average. So in moving average, what happens is we are going to uh, perform the average. So based on selected data points, say last n data points are taken to perform the moving average, or to calculate the moving average. So here we are importing the Arima model uh, because we don't have any direct moving average module here. But the first parameter is set as 0, so that is going to make it as moving average. So we are making first two parameters in order, that is auto regression and integrated as 0. So it will compute the moving average on the random data. The next is autoregressive moving average. It is the combination of previous two models, that is autoregression and moving average. Then third one is autoregressive integrated moving average ARIMA. Again, it's a combination of previous two, but here the additional parameter has been added. So that is integrating feature. So the integrating feature is related to the seasonality trends here. Not seasonality, sorry. It's related to the stationarity. So what happens is if your data is not stationary, then you have to make it stationary whenever you are performing time series forecasting. So that is what happens in ARIMA model. Then in Cerimo model, the seasonality values are added. So it directly combines the ARIMA model with the ability of again auto regression, then differencing, then moving average, and at the seasonal level. So it is suitable for again univariate time series or trend or seasonal components. So again, all previous methods, whatever we have discussed, they are all related to, or they are all suitable for uh, they are all suitable for univariate time series analysis. So there are some methods which are suitable for multivariate analysis, which we will see later. Now all these methods inside they use a Kalman filter for fitting the values using the predict method. Now next one is Cerimo model with exogenous regressors. Now here you can see here that we are using two data sets. So data 1 and data 2. So we are saying that in Ceremax function, the first parameter is the data and second parameter is the exogenous regressor values. So they are exogenous variables are also called as the covariates, and they can be thought of as a parallel input sequences. So that have observations in at the same steps at the original series. So that means at the same time there are multiple values which are being observed. So again, this method is suitable for univariate time series. Now, vector autoregression moving average. This uses autoregression and moving average methods combined with vectors. So this is suitable for multivariate time analysis, multivariate time series forecasting. So that's why you can see here that in this code the list is created, then the first vector is generated randomly, whereas the second vector's values are dependent on the first vector. So basically you need here two sets of values. So a row will be having both the values, vector 1 as well as vector 2. Now note here that vector 2's value is always dependent on the vector 1. So this is suitable for multivariate time series forecasting, but without trend and seasonal components. The next one is the holtwinsters exponential smoothing. So this method uses the smoothing techniques, uh, but specifically holtwinsters exponential smoothing uses triple exponential smoothing method, and it models the next time step as the exponentially weighted linear function of observations at prior time steps, then taking trends and seasonality into the account. So again, it is suitable for univariate time series, but with trend or seasonal components. Then next is the uh, package called as Profit. It is by Facebook. So it's open source software raised by Facebook's core data science team. So it's a procedure for forecasting time series data based on an additive model where non-linear trends are fit with yearly, weekly, and daily seasonality plus holiday effects. It works best with time series that have strong seasonal effects and several seasons of historical data. It's robust to missing data and shifts in the trend and typically handles outliers well. So you can visit this URL for more information. It also supports R. So it has been widely used in Facebook and its applications. And the next package is the darts. So it's a Python library for easy manipulation and forecasting of time series. So it contains variety of models from classics such as Arima to deep neural networks. The models can all be used in the same way using fit and predict functions similar to scikit-learn. Then it also makes it easy to backtest models and combine predictions of several models and external regressors. So it supports both univariate and multivariate time series and models. Then neural networks can be trained on multiple time series, and some of the models offer the probabilistic forecasts. Now, if you see this slide, then it shows the various capabilities of a DARTS library. So for discovery, it supports seasonality and trend checks, visualizations, then naive models. Then for pre-processing, it supports normalization, then interpolation of missing values, then seasonality or trend removal, then up or down sampling. Then it supports classic forecasting models, so which we have seen in our slides, such as AutoRegression, moving average, Arimax, etc. Then it also integrates the Facebook's Profit library and many others. Then for model selection and evaluation, it supports backtesting, then residual analysis, then grid search, and it also supports various metrics. So in summary, we had discussed about basics of time series forecasting, then different time series forecasting techniques, then different Python libraries for performing time series forecasting quickly, Of course, these are not the only libraries. We have also got other libraries, such as you can also go for TensorFlow. So there's a nice documentation available. Uh, so depending on your application, depending on the pattern in the data, you should be selecting the model. And when you're selecting the model, of course, there are different options. So you need to select that option which is giving you less error, as well as uh, the one which is performing better compared to the others. So thank you everyone for attending my talk. Thank you.
Thank you, Gajendra. We have a couple of questions for you from the audience. I'm going to read them to you. The first one is, what advice do you have for someone starting a time series project for the first time?
Okay, so if you're starting a time series project for the first time, then first learn about the statistics and different statistical methods which we have discussed. Then you should have uh, basic understanding of the statistics and mathematics. Then learn the basic libraries in Python. So pandas, data frames, numpys, scipys, stat models, they will help. Then you can learn a specific Python package which satisfies your requirement. Of course, we have got many options, but you should see which satisfies your requirements better. And then you have to select a domain in which you want to perform forecasting. So if you have a domain knowledge, then it's fine. If you don't have a domain knowledge, then you need to collaborate with someone and collect the data. And once you have the data, use the packages and you can start uh, the forecasting, or even start the time series analysis.
Thank you. Another question I have is about profit or darts, about performance. Do you have any benchmark for the performance of each library, which is more performant or better, maybe has a better use in other cases?
I'm not aware of the benchmarks, but yeah, maybe we may use metrics and test, but I'm not aware of the benchmarks.
So I think this is it, and thank you so much, Gajendra. And I want to ask the venue-less people to give a big virtual applause and thank you.
Yeah, thank you.
Next up on this stage in about 15 minutes at 2:30 Eastern European time, we'll have Malin Mangami talking about a beginner's guide to GPUs for Pythonistas. See you then.